The 7000 servo and controller have a enable input on the front. This is 5 to 24 volt input. The 7000 stepper enable input is pin 17 on the IO -0 connector on the top. Pulling these will immediately kill all motion and disable all drives. It won't stop the programs from running, but if the program commands a new move while this is on, then the motion program will halt. Other programs could still be running, and an error recovery program can be programmed to monitor this. When the enable input is pulled, it sets the axis kill all motion request flag and sets the kill on all the masters, which are the interpolators. The DACs are forced to 0 and the step pulse generation is blocked. This is a similar design as the previous generation ACR9000. For the inputs and outputs, each point has both the plus and the minus, so they can be used with NPN or PNP wiring. The outputs, when they're on, will connect the plus to the minus. The inputs are activated when current is flowing into the plus and out the minus. So for NPN sensors, you connect the plus to the high to the power supply. The minus of the input then gets connected to the NPN sensor. The NPN sensor is a transistor, so it needs power and a reference. For Parker sensors, they're blue, black, and brown. Blue is common, brown is plus, and black is the sensor output as normally open. Some have white as a normally closed signal. The current flows the same way. Brown and blue would get tied to the power supply, and then the black or the white wire would get connected to the input minus. So then the current flows from the power supply into the plus, out the minus, to the sensor, and then to common back to the power supply. For PNP sensors, the current flows out of the sensor output, so it would get connected to the input plus, and the input minus is tied to common. The transistor on the sensor still needs power and common connected, so brown would get connected to the plus on the power supply, and blue would get connected to common, and then the sensor wire black or white would get connected to the input plus. So current flows from the sensor output into the input plus and out the input minus to common, and that's how a PNP sensor would get connected to a 7000 controller input. The analog input option is the -ANI when ordering the controller. This includes 8 single-ended 16-bit analog inputs, or they can be wired differentially, and then you'd have 4 inputs. It's a spring clamp connector design. This info is getting a little into the nitty-gritty, but just to expose this to you, the hardware and the software tie together. Just like the inputs and the outputs correspond to bits, the axis connectors also have bits and parameters. For InCap, which we'll cover in programming, each axis reference mark can be used as the source for high-speed position capture. Mark 0 is for axis 0, mark 1 is axis 1, etc. The encoders are read into the encoder position parameters. So that's P6144 for encoder 0. P6400 is the DAC output, plus 10 to minus 10 volt for axis 0. If it's a servo axis, this will be controlled from the controller for the analog servo drive in torque mode, but you can check the status via parameter number 6400 for axis 0. The fault inputs are bits 64, 65, etc. for each axis. Bit 40 is the axis 0 enable output. When you do a drive on, it would turn on for a servo axis. This output can be normally open or normally closed, as that it's set based on the configuration wizard based on the axis type. For example, a servo has an enable input that's normally closed, where a stepper typically has a shutdown input that is normally open. that's where it'd be better to check the access status bit rather than the physical enable output bit. The drive reset bit is 48 for access 0 and would toggle when you do a drive res for the access.